Hi, welcome to my channel. In the previous video, we discussed about batch learning, batch learning and online learning system, machine learning, online learning, machine learning systems. Machine learning systems. These are the one type of learning systems. Now in this video, we are going to see one more type of machine learning systems that is based on the instance based machine learning system or versus model based learning systems. So one more way to categorize the machine learning systems is how they are going to generalize the system. So most of the machine learning tasks are about making the predictions. This means that given the number of training examples, based on the training examples, the systems needs to be able to make a good predictions. For examples it has never seen before. So simply it is called as a one type of technique. So having a good performance measures on the training data is good but insufficient. But it is insufficient. The true goal is to perform well on the new instance. Our main aim is it works on the training data as well as the unseen data. That is the main importance of our models. So there are two main approaches to generalization. One is instance based learning model and the second one is a model based learning system. So we see what the instance based learning system. So here the most trivial form of the learning is simply to learn by heart. So if you were to create a spam filter, like it would just flag all the emails that are identical to emails that have already been flagged by users. Not the worst solution, but certainly not the best one. So instead of just flagging the emails that are identical to the known spam emails, your spam filter could be programmed to as a flag emails that are very similar to known spam emails. This requires a measure of similarity. This requires a measure of similarity between the two emails. So a similarity measure between the two emails could be count the number of words they have in the common. The system would flag an email as spam if it has many words in the common. It's a known spam email. So this is called as a instance based learning. The system learns the examples by heart, then generalizes to the new cases by using a similarity measure to compare them to the learned examples. Simply it is called as a instance based learning. So here we're having the two types of data sets are there. One is a triangle and square box are there. So here whenever we are giving the new instances like square bracket, this is the cross mark, or this is the new instance. Now we want to classify so whether it is a triangle or square. So here the new instance is classified as a triangle because majority of the similarity instance belonging to the triangle class only. So here we are identifying the three elements are very close to this new instance. So here majority are belonging to triangle class. One class is belonging to that square bracket. So our new instance become a triangle class. So This is called as a similarity measure based on the similarity instances. So simply it is called as a instance based learning. So now another way to generalize from a set of example is to build a model of these examples and then use that model to make the predictions. So simply it is called as a model based learning. In the previous, we are going to classify the object based on new instance based on the similarity measures. But here we are going to build a model, mathematical model, in order to classify the data. So here, here we are going to predict the class label of this new instance. So in order to find out this new instance class label, we are going to predict one. We are going to develop one mathematical model. So based on that one, we are assign the class label. So here the line, the dotted lines represent developed by using some model. Here the cross mark or new instance is belonging to the triangle class. So here the new is assigned as a triangle class. So based on that one, you can see an example here. Suppose you want to know if you money makes people be happy. So you don't we are using some data sets from the Better Life Index data from the OECD websites and gross domestic product like GDP per capita from the IMF's website. Based on that one, we are going to join the two tables and sort by using the GDP per capita. Our aim is here we have to find out the life satisfaction of one country, particular country, based on the OECD life index data and GDP data. Those two data are available from the OECD's website and IMF's website. So based on these two tables, we are going to apply the joining the two tables, then start with the GDP per capita. Now we are getting the new one table that is called as a does money makes people happier. So here we are combining these two tables. One is Better Life Index data and GDP, gross domestic product per capita. So we are getting the new table here. Okay, so it contains a country, GDP per country, and life satisfaction. Okay, so for this table, if we draw plot the graph between the GDP versus life satisfaction. Okay, the graph, the plot is look like this one. Okay, so here the data is noisy. It looks like a life satisfaction goes up more or less linearly as the country's GDP per capita increases. So you decide to model the life satisfaction as a linear function of the GDP per capita. So we are developing one model for the life satisfaction as a linear function of the GDP capita. So this is called as a model selection. By the model selection, we are going to establish some relation between the life satisfaction versus life satisfaction and the GDP per capita. We should select a linear model of the life satisfaction with one attribute called as a GDP per capita, like life satisfaction. Okay, so simply y equal to mx plus c. Okay, so here y equal to simply life satisfaction. Theta not equal to simply a constant value. Theta 1 is called as a slope value as a m, and GDP per capita is nothing but simply x. So here the one variable is GDP per capita x. This is called as a x, and this is called as a m, and this is called as a c, and this is called as a y. So y equal to c plus mx. So simply this is a linear equation. So here in this linear model, the life satisfaction depends on the life satisfaction of the particular country depends on the GDP per capita with some slope, okay, with some theta 1 value plus some constant value. So this is simply a linear model. So this model has two model parameters. One is theta naught and theta 1. So now based on these parameters, we can make your model depend as a linear function. So you can draw the different linear models with the different values of theta naught, and theta 1. Suppose theta naught equal to 4 and theta 1 equal to 5 into 10 power minus 5. This is the one line. And theta naught equal to 0 and theta 1 equal to 2 into 10 power minus 5. So it gives the one type of linear line. Like that we can draw any number of lines with the help of different theta naught and theta 1 values. But these linear models are not fit for our data. So we are going to use your model. You need to define the parameters of theta naught and theta 1 is very important. So how can you know which values will make your model performs best? That is your problem. To answer this question, you need to specify a performance measure. So we can either define the utility function, the utility function or fitness function that measures how good your model is, and or we can define a cost function that measures how bad it is. So here there are two things are there. One is a utility function and a cost function. Utility function is measure how good your model is, and cost function measures how your model is bad. So based on these two parameters, we can identify your things. So for linear regression problems, people typically use the cost function. That measure the distance between the linear model's predictions and training examples. So the objective is to minimize this distance. That is very important. This is where the linear regression algorithms comes in. You feed it with training example, and it finds the parameters that make the linear model fits the best for your data. This is called as the training the model. In our case, the algorithm finds that the optimal parameter values for theta naught, equal to 4.85 and theta 1 equal to 4.91 into 10 power minus 5. So 10 power minus 5. So based on these values, we get the best fit for our data. So with the help of our theta naught and theta 1 value, by changing the different values of theta naught, theta 1 value, okay, our model, we are getting some model that gives the best model. So based on this model, fits the training data as closely as possible. Okay. So we are finally ready to run your model to make the prediction. For example, you want to know how happy separatists are, and the OECD data does not have the answer. Our aim is how the separatists are happy, but the OECD data does not have the answer. To give that answer, okay, your model is going to predict the corresponding life satisfaction of the separatists. So we look up the Cyprus GDP per capita of the Cyprus, and we can, that is $22,587. Then apply your model and find the life satisfaction is likely to somewhere around the 4.85 into plus $22,587 into 4.91 into 10 to the power minus 5. That gives the life satisfaction of our Cyprus countries. So thank you for watching our video. In the next video, we are going to see the program part of this linear model. Thank you.